take a look at this class is designed to reflect a marriage between two disciplines that help us understand both the structure and function of the human body. So it's just a class is designed to describe the relationship between two disciplines that help describe the structure and functions of the human body. We know that physiology and anatomy are sub-disciplines of a larger body of science called. And as we take a look at these two partners in this marriage, both anatomy and physiology, we look at anatomy, the one component of this marriage. And how can we describe anatomy? How would we describe anatomy? The structure.
The study of the structure.
The study of the structure of the human body. Exactly. So anatomy is just the study of the science of the structure of the human body. Now, I'll be up front. I do a lot of abbreviations. If you don't know what abbreviation is, what it stands for, just ask me and I'll just say exactly what it stands for. So anatomy is just the study or the science of the structures of the human body. So if you take a look at anatomy, it looks at the physical relationship of the different body parts. BP is for body parts, not blood pressure. So it takes a look at the physical relationship between the different parts of our body. So one component of this marriage is anatomy, which is just the science or the study of the structures of the human body, and it takes a look at the relationship between one part of the body to another part of the body. Now we take a look at the origin of the word anatomy. It's derived from the word anatomize. And anatomize is a Greek word which means to part. And most of what we know, virtually all of what we know, the physical relationship of the different parts of the body is derived from what? Dissections. When we say anatomize, to cut apart. So most of our knowledge that we derive about the physical relationship between different body parts is derived from the dissection of the cadavers, to gain us our appreciation of the different physical relationships of the parts of the body. So we have dissection of the cadavers helps us gain an appreciation of the physical relationship of the different parts of the human body. Now, take a look at anatomy. There's two major fields of anatomy, fields of study. There's two major fields of study. Of anatomy, and these two major fields of study, we have both what? Gross anatomy and what? Microscopic anatomy. Two major fields of study. So how do we study the structures of the human body? We can study it in two ways. We have gross anatomy and microscopic anatomy. There's two major fields of study, gross anatomy and microscopic anatomy. Now, right here in the yellow shirt, what's your name? Brianna. What is gross anatomy?
Like the overall view of what you can see.
So the big picture, or so be more specific, is the study of structure that does not require what? Magnification. So when we talk about gross anatomy, these are large body parts. It's the study of structure. There's a study of structure, as for study of structure, that does not offer magnification. Are we cool with that? It's a study of structure that does not require magnification, and there's certain different types of gross anatomy. We have what's called systems anatomy. Systems anatomy we're looking at all those body parts of a particular organ system that can be visualized without application of a microscope. If we think about that of the cardiovascular system, we can see the heart without using a microscope. We can see the large arteries and veins without the assistance of a microscope. So systems anatomy is the study of the structures of a particular organ system that does not require what? Magnification. Another type of gross anatomy, regional anatomy. And we say regional anatomy, we're just studying all the parts of a particular region of the body that does not require magnification. So if we take a look at the upper extremities, take a look at the brachium, the antebrachium, we're looking at these structures such as the bones associated with the arm, the muscles, the nerves, the blood vessels that do not require a microscope to be visualized. Are you okay with that? So regional anatomy just refers to the structures that can be seen without magnification associated with a particular region of our body. Then we have surface anatomy. And Ebony, what do we mean when we say surface anatomy?
Line surface relates to like muscles, how we visualize the structure without actually the internal.
So we're looking at the relationship between what? The internal structure as it relates to our what? The overlying skin. So we take a look at surface anatomy. Surface anatomy is the study of internal structures, the study of internal structure as it relates to the overlying skin. So surface anatomy is the study of internal structure as it relates to the overlying skin. And you think about the practical application of surface anatomy. If you go see a physician, go to the doctor's office, one of the first things they might want to do is what? Draw blood, do a biochemical analysis of your blood profile. What they will do is they'll try to identify what's called the median cubital vein. So we have the medial cubital vein, and they use surface anatomy to identify this vein right here, insert a needle, draw blood to do a biochemical analysis of your blood. So they use surface anatomy to identify structures. This is our median cubital vein. And they employ a tactic called palpate. When we say palpate, what do we mean when we say palpate? To feel an organ with our what? Hands. So when we use surface anatomy, we're palpating structures, identifying internal structure as it relates to the what? Overlying skin. Are you okay with that? Is everybody cool with that? So, medial cubital vein can be identified by palpating. So we palpate the location of this vein as it relates to the overlying skin. Are you okay with that? So this is just taking a look at one of the major subdivisions of our anatomy, gross anatomy, visualizing structure that does not require what? Magnification, surface anatomy, regional anatomy, systems anatomy. The other will be microscopic. Microscopic anatomy, as the name implies, is the study of structure that requires what? Magnification. So it's a study of structure that requires magnification. Study a structure that requires R for requires magnification. And the limitations of microscopic anatomy will be based on the what? Resolving power or the what? Magnification power of your what? Microscope. So depending on how powerful the tool is, will let you know how much internal structure, microscopic structure you can see. When we talk about microscopic anatomy, we have two major fields of anatomy. We have cytology and cytology. Heidi, what is cytology? Study of cells. Study of cells. Is that right or wrong?
Study of the internal structure of cells.
The internal structure. So key word here, we're talking about anatomy. So cytology is the study of the structure of what? Cells. So study of cell structure. And then we have that of histology. And histology would be the study of what? Tissue structure. So the study of tissue structure. So histology is the study of tissue structure. Are we okay with that? Keeping in mind, we're talking about anatomy. We're focusing on what? Structure. We're focusing on structure. All right, so we have one partner in this marriage, that being the anatomy component. Then we have our physiology. And how can we describe physiology? Physiology, or human physiology, be better described. How can we describe human physiology? The study of the function of the different parts of the what? Human body. Are we okay? I'm just going to put the study of function. Of the functions of the different so human physiology, we can study the functions of the different parts of the human body. Are we okay with that? So if we can study the function of the different parts of the human body, physiology is derived from a Latin word physio, which means the nature of, and the something is how that thing what functions. Are we okay with that? So we're looking at the other partner of this marriage. Physiology is the study of the function of different parts of the body. There's various different types of physiology. We call systems physiology, in which we study the functions of the different parts of the different organ systems, like cardiovascular physiology, renal physiology. Are we okay with that? Where we study the functions of the different components of the organ systems of the body. Then we have the cornerstone of physiology. We have cell physiology. And how can we describe cell physiology or cellular physiology? The study of what? Cell what? Function. So cell physiology is the study of cell function. And this is pretty much referred to as the cornerstone of physiology, because what the cells can do will ultimately determine what the what? Body can do. Are you okay with that? So what the cells can do ultimately depends on what the cells can do. We always want to get to the larger body parts, but we need to be able to what? Understand what our cells can do. And once we understand what the cells can do, we understand what the tissues can do. And once we understand what the tissues can do, we can understand what do, and then what organs can do, make up our organ systems. Then we can understand the capabilities of the human body. So always, as a scientist or as a biology major, you want to always understand both the what? Structure of the cell, which we get by cytology, and then you also understand the what? Function of the cells, and we'll get that by what? Cell physiology. This is the basis right here, cell physiology and cytology. Understand that, you want to build upon that to understand the functions of the different parts of the body. Are you okay with that? You're making sense. Now, in this class, we're taking a look at physiology and anatomy together, so we're taking a look in tandem. These classes, or these disciplines, can be looked at this way, but as we take a look at them together, this introduces the theme that's intertwined throughout this entire textbook, and that's the complementarity of structure and function. So when we look at both anatomy and physiology in tandem, we look at the theme complementarity of structure and function. So when we take a look at physiology together, we introduce the theme, the complementarity of structure and function. And what does that mean? Dallas Maverick fan. What's your name? Carlos. Like Maverick? What do we mean when we say complementarity of structure and function? Say again? Two organs? All right. For a second, you put it just too deep in there. I don't understand it.
The way structure and function complement each other.
to work. So you're saying if you understand the structure of a particular body part, we can use what that body part can what? The function of a body part. Exactly. Nicely said. So complementarity of structure and function just says if we understand the structure of a particular body part, we can deduce what that particular body part can do. So if we take a look, for example, at this theme, complementarity of structure and function, we take a look at an organ. This is the human heart, and as you take a look at this complementarity of structure and function, you take a look at the heart, for example. You think about the tissue profile of the heart. The heart is made of what type of tissue? Say again? Muscle. So it's made of cardiac muscle, the myocardium. So our heart is made up of muscle. So we say muscle, so the majority of the heart is made up of cardiac muscle, what we call the myocardium. If it's made up of muscle, okay, so structurally it's made up of muscle, we're okay with that. Then what's going to be the function? What does muscle do? Muscle provides what? Movement. So if it's made up of cardiac muscle, muscle is involved in that of movement. You know the heart will be involved in the movement of something within the body. Are you okay with that? If you take a look at the structure of the heart, it has 4 chambers. It has 2 receiving chambers we call our atrium. We have our 2 receiving chambers, and then it has the ventricles. The lower chamber, take a look, structurally, the internal anatomy of the heart, it has 2 superior chambers we call atria that receive blood. Are you okay with that? Then we have 2 lower chambers that will eject blood. Are you okay with that? As you take a look at the structure of the heart, we have the right side and the left side of the heart. The right atrium, our will receive deoxygenated blood. It will receive deoxygenated blood. Are you okay with that? Deoxygenated blood will go from the right atrium to the right ventricle, and then the right ventricle will eject that blood to the what? To the lung, to the pulmonary trunk. So the right ventricle will eject that blood into the lungs. When we take that deoxygenated blood, this D stands for deoxygenated blood. We take the deoxygenated blood to the lungs, we'll have what? Gas exchange, where we release the what? CO2 and pick up what? O2. Then we take a look at the left side of the heart. We have our left atrium, which will receive oxygen-rich blood. Are you okay with that? It will then receive that blood, pump it into the left ventricle, and then the left ventricle will pump that blood into what's called the what? Aorta. It can then take that oxygen-rich blood to all the cells of the tissues of the body. So we take a look at the heart. It's made up of cardiac muscle, so we know it's involved in that of movement. The movement will be that of blood from the lungs, ultimately to the cells of the tissues of the body. We look at the heart, it's also equipped with valves. We have these heart valves, and these heart valves will ensure that deoxygenated blood will go from the right atrium to the right ventricle, from the right ventricle to the pulmonary trunk, we're injecting the deoxygenated blood. Then we have oxygenated blood coming into the left atrium, we pump it into the left ventricle, and then it exits by way of another heart valve into the aorta. So structurally, this prevents backflow of deoxygenated blood from the left ventricle into the right. We want the deoxygenated blood from the right side of the heart to the lungs, return back to the heart, and we inject that oxygen-rich blood to the cells of the tissues of the body. Are you okay with that? So we're taking a look at the complementary structure and function. When you take a look at the structure of a particular body part, you can begin to deduce what that particular body part is capable of doing. Does that make sense to anybody? Are we okay with that? So we want to go ahead and take a look as we begin our examination of the human body. We'll see that the human body exhibits levels of structural organization. So our human body exhibits levels of structural organization. And these levels of structural organization are hierarchical. So we have higher levels, and then we have lower levels, or our lower levels will give rise to levels. So these levels of structural organization are hierarchical. And we have what are called emergent properties. And what we say by emergent properties, we're saying that as we move from the lower levels of structural organization to the higher levels of structural organizations, the higher levels have capabilities that the lower levels do not have. So as we go from lower levels to higher, the higher levels of structural organization of our body, these levels have higher to perform different functions. So we take a look at the first level of structural organization. And what's the first level of structural organization of the human body? Chemical. So we have the chemical level. So we take a look at the chemical level. We know, think about that of chemistry, the study of the structure and interaction of matter. All right. Building blocks are matter. Building blocks are matter. Matter is made up of what? Elements. With that, you guys with me? So we're saying we look at the chemical level as the first level, and we think about the human body, HP for human body, and a normal, healthy individual will consist of 26 different elements. So our body has 26 different elements. Of this 26, 4 different elements make up 96% of the total body mass. 4 elements make up 96% of the total body mass, TBM, or total body mass. So of the 26, 4 make up roughly 96% of the total mass of our body. And as we take a look at these 4 key elements associated with one of the structures of the human body, there are 4 key elements. Take a look at the levels of structural organization of the human body, and we're at the chemical level. What element makes up the majority of the total composition of the body? Has the highest composition? Oxygen. Oxygen. So we take a look. So we have oxygen. For oxygen is what? O. What's the atomic number? Atomic number? 8. 8. Atomic mass is 16. Everybody? Look at the percentage. What's the percentage of oxygen that makes up the total body mass? Roughly 65%. So oxygen makes up approximately 65% of the total body mass. And why is oxygen so important in the human body? Kelly. Right here. Madam. Right here. What's your name? Tori. Why is oxygen so important to the human body? We're not going to comply with that. Correct? Why is it so important? We need oxygen. Oxygen is a component of what? Cellular metabolism, but also it's a component of what? Water. Our bodies need around 5 to 70% what? Water. It's a component of water. So it functions as a component. Are you guys all right with that? Of water. Also, we know it's a final what? Electron acceptor and what? Cellular respiration. Maximize what? Energy extraction through aerobic cellular respiration. So it helps us extract energy. In cellular or aerobic cellular respiration to generate our ATP. Is everybody okay with that? So oxygen makes up roughly 65% of total body mass. It's a component of water, and it's responsible for maximum extraction of energy. Think about glycolysis is only aerobic. Anaerobic. We don't require oxygen, but most of our ATP is generated when we have oxygen, sending those electrons down the electron transport chain. We think about the most abundant element that makes up the total body mass of the human body. Madam, right here. What's your name? Alexander. What should be the next element? Exactly. Good deal. Chemical symbol for carbon is what? C. Atomic number is what? 6. Atomic mass is 12. It makes up roughly 18.5% of the total body mass. And why is carbon important? Alexander, right? What's it again? Why is carbon so important? Carbon? Why is carbon important? This is 10:15. This is 10:15 from chapter 2. It's key for all our what? Biomolecules. It's a component of what? Carbohydrates, your protein, your lipids, your what? Your nucleic acids. So it's a key component of our biomolecules, such as our carbohydrates. That's for carbohydrates, proteins, lipids, Na for nucleic acids. Then we take a look at the next most abundant element. Actually, that would be that of what? Amber, I'm sorry. Hydrogen. So we have hydrogen, chemical symbol H, atomic number 1, mass is 1. It makes up roughly around 9.5%. Hydrogen also is a component of what? Water. Also, what happens when hydrogen ionizes, when it loses an electron? The hydrogen ion determines what? The hydrogen ion determines what? pH of a solution. So when it's ionized, our hydrogen ion concentration determines the pH of the solutions within the body, which is pivotal to maintain overall homeostasis. We have a very tight window for the pH of our blood, intracellular fluid, different fluids in our body have to have a critical pH in order to allow normal protein function. And the last of the 4 key elements that make up 96% of the total body mass will be that of our nitrogen. Atomic number is 7, mass is 14. It makes up roughly 3%. And we need nitrogen in order to what? Synthesize our what? Proteins and our what? Nucleic acids. So it's a component of both our proteins and our nucleic acids. We know that atoms are governed by the octet rule. So atoms will interact with other atoms to form our what? Molecules. Molecules will interact to form organelles. So we go to our next level of structural organization, which would be that of the level number 2, would be the cellular level. So as atoms interact with other atoms to fill their outer shell with the maximum number of electrons, we form our molecules. Are you okay with that? Molecules will interact with other molecules to form organelles. And organelles are intracellular structures that have specific functions in our cells. So we look at the cellular level. This takes us to the cell theory. This is in the early 1800s, 1830s. We have Schleiden and Swan. scientists that came up with the cell theory. And what are the tenets of the cell theory? What does the cell theory state? It states that what? All living things consist of what? Cells. The human body consists of trillions of cells. So one component of this theory is that all LO for living organisms consist of cells. They also state that the cell is the functional unit of life. So it's a small, has the capacity of maintaining the processes associated with life. So it's a functional unit. So the cell is a functional unit of life. And then also this theory states that all cells arise from what? Pre-existing cells. So all cells from pre-existing cells. And we get into chapter, I believe it's chapter 3, we're already assuming that you understand or know the general structure of a tract cell associated with the human body. We're giving an assignment to make sure to refresh your understanding of those components. So we go from the chemical level to the cellular level, and this is a major jump. Major atoms do not have the capability of what? Cells. So this is highlighting when we say the emergent properties as we go from one level to the next. This is a major jump going from an atom of carbon, atom of nitrogen, oxygen, hydrogen, to that of forming cells that have the capacity to maintain life. This is showing what we're saying with regards to emergent properties as we go from lower levels to higher levels. The higher levels have capabilities that cannot be performed by the lower levels. Our cellular level will take us to the next level, which would be that of our what? Tissues. At the tissue level, how can we describe tissue? Right here with the red Nike shirt. Okay. How can you describe tissue? Histology, study of tissues. But if you describe a tissue, if you talk to your little brother or little sister, you say you got the cell, and you got the tissue. Right. It's just a group of what? Similar cells that work together that will what? Perform a what? Particular function. So a tissue will just be a group of similar cells. Are we okay with that? That work together to perform a specific function. Are we okay with that? And we think about the human body, we think about our body, the human body has 4 major tissue types, or 4 primary tissue types. We have 4 primary tissue types. And the 4 primary tissue types associated with our body, we have what? We have our epithelial tissue. So we have epithelial tissue. We think about epithelial tissue will cover the surfaces of the body. So what is epithelial tissue? It covers the surface of our body. Look at our skin. This is our stratified keratinized epithelial tissue. So we have, it covers the surfaces of the human body. Then we have our connective tissue. What's an example of a connective tissue? Muscle? Bones? Are we okay with that? Cartilage, blood, adipose tissue. These are all types of connective tissue. Don't worry. Be happy. We'll get into all of them when we get into chapter, I think it's 4. So connective tissues, they help to provide support the body. Bones are a type of connective tissue. Cartilage, tendons, ligaments attached to bone, bone to bone. Then we have muscle tissue. How many different types of muscle tissues associated with your body? 3. You listed one already. You listed what? Cardiac muscle, myocardium. Then what other type of muscle tissue we have? Skeletal muscle. And then we have smooth muscle. So we have 3 types. Cardiac, skeletal. This is the muscle associated with your bones. And then we have our smooth muscle tissue. And we said the general. Is it time to go? And then we have our nervous tissue. What's the, no, I'm trying to get you out there. What's your name?
Vivian.
Vivian. What does nervous tissue do? What's its function?
The function of tissue?
Yes, ma'am.
It would be.
Your MD, PhD. Yeah.
The function of nervous tissue would be, well, to, what is it called? That's what I'm looking for.
You're doing it right now.
Send signals and hormones to the body.
So communicate. Right?
Communicate, right? Exactly. That's the word I'm looking for.
So nervous tissue is involved in communication. It doesn't send the hormones, it sends the neurotransmitters.
Oh.
All right, is it time to go?
Yeah.
All right, so we'll continue. We have lab tomorrow. And I apologize about